In this chapter, we started with the operating system structure as a concept to study. As a sub-points, we have gone through with many like OS services, user interfaces, then system calls and types of system calls. Okay, so as a revise or a revision for a while, let's see what we have studied. We have seen what are the services operating system will provide with respect to user, program, then file system, error detection and communication, so on. Some of the services we have seen. Then we have noticed the important, it's a view of operating system services, how it looks like, one side hardware, another side user, through different interfaces like a graphical user interface, line or command line interface, or through batch system. User will give a input, so based upon that hardware will work, okay, or hardware will provide a service. So to establish a communication between these user inputs and the hardware, so we have an intermediate environment called operating system. So and to make operating system to perfectly execute all the requests, we have system calls. Okay, so in the second session of this chapter, we have seen how the individual command line interpreters are there. Okay, so then comes what is importance of graphical user interference. Okay, then comes here graphical user interface called as icons. Okay, so some of the case study we have seen Mac OS icon. Okay, then we have seen what you mean by system call. Those are predefined programs, whatever we do using either whatever we do in the computer as a system, so the system should provide a best environment, and in the background there should be predefined procedure. So based upon that procedure only we have to get work done. Okay, so those are called as system calls. So one of the important diagram we have seen how a system call will execute during copy of a content from one file to another file. So many different operations will take place, though which all the operations we have seen. Okay, then we have seen standard API execution, application program interface, how it executes, what are the parameters it will collect for its execution, what will be its output, whether it is a success execution of API or failure execution of API. Everything depends upon the type of parameters we are passing and correctness of the parameters. Then comes system call implementation. So how a system call is successfully implemented, through this diagram we have seen. User will give one program, simple double click on a file or an icon. So double click is called as open. For us it is a double click. For operating system the name is open. So once it is open, among so many system calls, one perfect system call will execute. What is the system call? Name is open. What do you mean by open? Implementation of open means execution of open. So as we double click on that file, something will take place in the background. First thing, whether the file is existing or not, that is checked. If file is existing, then whether user is allowed with the permission or not. If yes, whether the permission is only for read or read write or only write, etc. So those all things will be stored. Then after that, okay, whether say for example I have double click on some music file, whether the music file is defaultly VLC player or some other music players, so these all things will be observed. So that makes a system call. These all activities will take place, or check operations will take place in the behind whenever we go for a system call called double click, GUI called double click, system call called open. Okay, so how we are passing parameter for a system call? Say, is it required to say the name of a file or name of the icon to open? That means Say for example, my statement is like this: open the door of your home, open the door of a classroom, open the door of lab room. See the differences. All activities are same, but they specify what is that the thing which making environment different from each other is that parameter. Open door is the same, open the door word is same, but only difference is what I am passing a parameter. First parameter home, second parameter the classroom, third parameter the lab room. See, based upon that parameter, the effectiveness or the result keeps changing. Same way, to execute a system call, we have to pass some parameters. So those parameters we are passing through registers. Okay, so in some cases we can directly pass the values, because registers means what? Which holds the values. In some statement, in some condition or some time, we should say only the address. Especially this happens when we are working on files. So every time we cannot say the file. To access the file, to close the file, anything we wanted to do, it is allowed only through pointer. So what is default meaning of pointer? Pointer means address. So that means we are indirectly passing a parameter as a address, or address as a parameter. Through that address we are fetching the information or modifying the information or anything. Whatever the operation we do, like read, write, open, close, modify, these all are system calls. These all are done not directly by the file, instead by the file pointer. If it is a file pointer, definitely it is going to be an address. Okay, so third parameter, third mode of parameter is by pushing or placing the content on stack. Say for example, there are 3 files to open, and the content of each file: first file A, second file B, third file C. All 3 have 3 diagrams. I want to copy all these 3 diagrams into fourth file. Fourth file is not yet created, it is not yet present. So what I have to do? First file I will open, minimize. Second file I will open, again I minimize. Third file I will open and minimize. So as soon as I have not yet completed the work, all the 3 files I have kept open, and the 3 file pointers are assumed as they are stored in the stack. Okay, so once they are stored in the stack, at this stage I will open a fourth file with a fourth file descriptor or a file pointer. I will take a content from first file and create it on the copy it on the fourth file. Now I have option, either I can keep first file or I can close it, because my work is done. Okay, so then comes second file. I will open, already it is open, which I have minimized. Now I will maximize, I will collect the data from it, and again I will copy in the bottom side of the contents of the fourth file, which I have already copied on the top side from file number 1. Same way, now I have option for file to either close or minimize. Okay, once the second file content is copied, now I am going for maximize of third file. See, during this minimize and maximize, it is assumed that file pointers of file A, B, C all are popped from the stack. This is one more method of passing a parameter for a system call. Okay, so finally what happens in the fourth file? We will get the diagrams from file A, file B, file C, and all the 3 files we can assume they are closed. Now only one file is open, that is a fourth file, that is called as D file. So in that we have all the 3 diagrams copied. So if we want, we can close it or we can refer it for our reference. Okay, so see how this is concept. So there is one user program and operating system. So what this will do is, it will give through the register. So through the register, what address of X, where address X is present somewhere in the OS. Okay, So this address of 13 is forwarded via the register. So what is system call for 13th system call is already stored here. So what you can assume in the top, 2 3 1 12 11 10 etc. up to 0. Here you can assume 14 15 16. Address is forwarded via register, system call is directly called. Okay, so what this this one ash color consists of is, it's a sub activities, arrangement of sub activities what has to be done when system call 13 is called. That will be there in the brown this ash color area. Okay, so parameter passing, it is only through this register. System call directly you can call some area of operating system. Okay, so do we have types of system calls? Yes, with respect to process, with respect to file, with respect to device, with respect to information, communication, and finally with respect to protection. For every main category we have subcategories which are very simple. We can go by even general English also we can write. So now let's go for first type of system call with respect to process. So what all the system calls? For process, what are the predefined functions, and I have to use the same whenever I wanted to work on process. Okay, so with respect to process we have system call for process creation, process termination. So process creation is fork, termination of a process is by many options, DEL, KILL, RM. These all are the activities or commands you can say, or you can say like system calls. So not only termination, we have a end, automatic ending of the process. Abort, if resources are not available or if process is not possible to complete its execution on time, we can go for abort. So load of data, execution of the contents present in that file or in the process, that means process execution. Get process attributes, what is the process parameters, set process attributes. Like that we have plenty of system calls related to the process. Okay, so dump memory if there is an error in the process. So process is trying to do some activity, but it definitely leads to an error. In that situation what it is called is dump memory. Okay, so can we lock a process? Yes, for that also we have system calls. Okay, see, very simple. How to what we can give a real world example is, see, try to create one painting in our own mobile. Okay, so one painting, simple painting like drawing a triangle and in my mobile only and saving it in my mobile. That's one activity. Okay, so if I don't want to create on my own, what is another option I have? I can borrow it from my friend. Okay, so that means what, finally I can have a file or something in which a white sheet is there. In the white sheet we have drawn a triangle with a different color. Okay, so system call means either you can develop in your own mobile or a computer, or you can get it from your friend, but thing is you should have in your device. So that is one example. Like that, to do some activities in our computer or in a mobile, so we should have all the inbuilt facilities, so I can do that work, complete the work, and upload the work, etc. So here with respect to file, what all the system calls: file creation, file deletion, opening a file, closing of the file, read from the file, write into the file. Okay, then get and set of file attributes. Attributes means permissions, whether a person is allowed to use or not allowed to use. If allowed to use, only for read or only for write or both for read write, etc. Like that, for every action whatever we wanted to do in the computer, there is a inbuilt system call. Okay, so with respect to devices, okay, so what are the things? See now, very simple way. If you connect mobile to the computer, or in the mobile network, computer is connected, every time it will ask permission, okay, through in the name of password. So that is called what? Request for connection. Request for connection. Even if you attach one your pen drive to computer, so computer will give you message like a USB device has detected. So next what you will do, after your data transfer and all, you have finished the data transfer between computer and USB pen drive. So what you will get in the next is a release. So what you will do, you will double click on that save to remove, or you can right click on that eject. So that means what? You can, for release of devices, there is also one system call. So read from the pen drive, write into the pen drive. Reposition means modification in the pen drive. So there is one project file, in that you have typed a letter, means report. Okay, so do you want to read that report in your computer? Yes, for that also there is one system call. For write also system call, etc. So next one, get device attributes. Once you connect a mobile, okay, so can you check how much internal memory is available, how much is filled? Okay, can you change the operating system of a mobile which is connected to the computer? Like that, you have some are allowed attributes, some for some activity it is not allowed. Okay, so attach and detach of the devices. So for those also we have system calls. Next, system calls with respect to information maintenance. So what is date? How? See, there are two ways to ask computer what is the date today. Okay, so what generally we will do, we will see right side bottom of the screen, and immediately will come to know. Okay, so what is another option? Same right bottom, double click, you will get what? This here. Let me try to show you. Okay, fine. If you right click on right bottom side of the screen, you will get a calendar. So if you don't want to do this, what we have to do is go to command prompt, type there date command, DATE. So you will get in the row. So that means what? To get information, you have multiple way. Any way we do internally, it is going to be on standard system call. Okay, so get the system data and set the system data. So some of the data like who is a username, what is a username, what is his privileges, etc. So these all you can also change, or whatever you have set previously you can also modify. So those are called as, for this activity there is again system call. So now you can ask, what do you mean by system call and what it is important? See, whatever you wanted to do in a computer, you will try to give in your own language, like double click or touch screen, etc. But computer will never understand what you are doing. So what computer will do, based upon your input type, like a double click, single click, voice search, like a Siri, etc. So what it will do, it will convert whatever it has received from user side to something which is inbuilt already. Okay, so it will try to relate with that. So which matches best, according to that it will behaves. That is called as system call. Okay, with respect to communication, start a communication, delete the communication. That means connect with the Google, disconnect with the Google. Okay, send a message, receive a message from a friend, download a file and upload a file, transfer of the status. See, transfer status means what? You are trying to upload a file. 50% of file upload is done, another 50% is remaining. Like that, we can through internet we can connect to the computer printer and we can disconnect it. So these all, for everything we do in a computer, we have definitely one of the system call will execute in the background. So with respect to protection, we have control access to the resource. Do we have access or not? A particular user is allowed to access or not? If yes, what are the permissions he has and what he can do, what he is not allowed to do? like that. If he doesn't have a permission, deny the user. So these are for everything we do in a computer. There is one standard system call which is already defined. Okay, see this in Windows and in Unix. See what we will do. We will double click on some icon, double click on a file. So what we call it as create a file in Windows, we call it as open a file in a Unix. Like that, there is a comparison. Hope you will get to this rightmost column Unix in your one of the subject very soon. Okay, so next, how one standard C library. See this C library, how it executes. The question is, C program take a help of with the help of printf, it will print something on the monitor. So if it prints, what is the activity name? Writing. Okay, so print means writing on the monitor. How it works? We have printf in this part of the program. What is there? Greetings. So printf is in user mode. Okay, so in the standard C library there are n number of libraries. In that one library is print function. Okay, print function. So immediately it come across a printf, it will shift from user mode to kernel mode. Printf means write work, because it has to print something on the monitor. See, not only the write work, so many works will so many system call will happen. See, once we see the printf line in our program, one thing, check monitor whether it is correct or not, whether it is free or not, data, communication, because from CPU the data should be sent to monitor, so conversion of the data, these all system call will take place. Finally what we will see, because of a printf I can see something on my monitor called greetings, welcome to JCET Hubli, welcome to operating systems. Like that, we can whatever we wanted to see it on the screen, that we can see through the help of printf. The word printf is for us only in terms of C language, but for OS it is a write work or write system call. Okay, so in the MS-DOS, okay, disk operating system, Microsoft disk operating system. So what happens? There is a kernel, there is a command interpreter, then there is a free memory. Assume that free memory is more, that means there is no workload. Okay, so some process will get created, and as the process will get created, they use some space. Okay, so what happens? Kernel and command interpreter, so those will be present even before and after usage of a existence of a process. But as the process number of process or complexity of process increases, free memory size decreases, processor size keeps increasing. Okay, I hope it is clear now. So next, system programs. It provides one of the convenient environment so that program will be or activity will be executed. See, previously what is the difference between system call and system program? Group of system calls is called as one system program. Group of system calls execution is called as one system program. So for file manipulation we have a system program, for status information we have a system program, for establishing communication from one computer to another computer again we have a system program. Like that, for every work operating system will do or every service operating system gives us, so there exist many number of system calls. The proper arrangement of different system calls execution makes one system program. Okay, so next, with respect to file, what are the system in program level? So for creation we have, I told we have system call, so there may be many types of files creation, creating a music file, creating a drawing file, creating AutoCAD file, creating one video file, etc. See, those all with respect to file, whatever we do, they all will be in under one program shelter called file management system program. Status information. So some of us will ask what is the date today to the computer, what is 2 plus 3, what is 6 star 5, like that. For everything we ask through C program. So that means what, here we can means status, whether the question will be is it possible, how much battery is remaining, okay, when to keep a charge, these all are called status. Okay, so status information, for that also only system call is not sufficient, so we have to go for system programs. Okay, so with respect to file, we have some of the system programs. So text editor, and for the editing of the text, and also for modification in the content of the file. So programming language support. See, if I write one C program and try to execute it in Java, so it is not compatible. Among the Java compiler, I have to select C compiler, then I can execute the program whichever I wrote in a C language. So like that, I have to use a perfect assembler and perfect debugger for identifying errors, converting that high level language to the low level language. All these activities we can do with only the help of multiple system calls. Multiple systems are called as one system program. That's why we have same headings. There it is a smallest entity, that there means system calls. Group of system calls will give us system program. Okay, so then here background services. So this is new for us. So what you mean by background services is, I will turn on a computer. Okay, if I turn on computer by power supply button, and assume still OS is not yet loaded, so something I can see between this on a black screen with a white alphabet, this is called as background services. So what are the background services? Keeping, okay, so for 15 days if I don't turn on a computer, who will keep counting my date and time? Even after 15 days, whenever I will turn on a computer, it shows correct date and correct time. So how it is possible? Because in the background, which is called as a boot time, init program will be there. That init program always will be alert, and it keeps counting time, alarm, etc. Okay, so even during printing and execution of some of the contents in the text editor or a kernel, we will see some background services. So application programs, what we have, not only system program, application programs, they run by the user. Just simple example, apps. VLC player is a app, WhatsApp is a application program, then Facebook is a application program. We operate on that application program. So but they convert into system program, again they convert into smaller entity called system calls, then they will execute on a hardware, they will give us the answer back on the application programs, application softwares also. Okay, so what are the things we have to concentrate when it is operating system design and implementation? Okay, so operating system design and implementation. So internal structure of every operating system different from one with each other. So Windows will be different from Unix will be different from Mac OS, etc. So they can have different implementation part or design part in their development of those particular operating system. So whenever we wanted to develop an operating system, goal or the target or a type of the operating system, whatever we wanted to develop, will be of different. Say for example, we want to develop one operating system for ATM machine. Its work is different, its nature is different. Next, I want to develop an operating system for some of the medical equipment like a CT scan machine or etc. So that time its purpose is different. So it will have different type of activities or design itself. So that's why the type of a system and what type of hardware we are using. So whether we are using a simple hardware like a computer, or we are using a special hardware like a CT scan machine, or the third case ATM machine where finance transactions will take place, so etc. So based upon the hardware and type of a system, so it's a design part and implementation part keep changing. So also what user will have the goal, what if I want to develop one operating system, I should concentrate both the side, that means user side as well as system side. I should not make it totally friendly for the user. So if I make it full friendly for the user, means anything he can do, then computer will never understand what user is doing in some situation, like ATM machine with, say for example, very user friendly, no need to give any ATM card etc., directly take up a money from the ATM machine. That is a wrong design. So that means I have to look after user targets. Also I have to look after limitations of the system as a hardware. So I cannot give the money from ATM like how much, whatever he wanted. So there should be limit for daily transaction, maybe monthly transaction, etc. So those all are the conditions. Okay, so those all conditions or limitations we have to think whenever we are designing for any of the operating systems. Okay, what will be much variations? Okay, so early OSs, they have assembly level language compiler, but in Windows 10 we don't have MASM. So MASM means it's one assembler which was built in Windows 98, even in Windows XP, but Windows 7, 10, Vista, those all don't have assembler. So system programming uses like Algol, PL, but now what we can see is system program uses C++. Okay, so generally what it is, it will be mix of many languages like high level language to assembly level as well as machine level language. But what we can do is, nowadays we can write one program in which part of a language, part of a program can be in one language, another part of a program can be in another language. Especially it is applicable for C and microprocessor. Okay, so you can see that. And some of the part of a program of a Python can be similar to the C program syntax. So like that what we can do is, so there will be some similarities and there will be some differences from one with each other. Okay, so how the operating system has it's a structure. So general purpose operating system and specific purpose operating system. General purpose operating system means Windows 10. Specific purpose operating system means software operating system used in ATM machine. Okay, so again that is different from operating system used in our mobile, that which is different from operating system used in CT scan machine. So which are the different modes we have? We have a simple structure, complex structure like a Unix, layered architecture, and microkernel method. So these are the 4 different types of operating system structures. So let's see one by one. Simple structure. So what do you mean by simple structure? It is going to be used, it has been used in Microsoft disk operating system. So what happens, user will have his application program, he want to play one music, listen to the music. So what he will do, he will double click on music file. So what it will do, it will identify inside that whether there is a system call present or not. Double click on music file means play, defaultly play. We cannot open a music file in MS Word. Okay, double click on music file, directly start playing. So it will start where it should listen the song, it should listen the sound or a song, it is on the speaker. So there should be connectivity from hard disk, RAM and a speaker. So a speaker is an extra hardware. Okay, so if it is extra hardware, it will think whether there is a device driver installed or not. So most of you are not aware about different device drivers, because nowadays Windows 10, if we install audio driver, video driver, graphic, etc., everything will come inbuilt. But what we used to do during Microsoft XP was, first we install OS, we need to install audio driver separate. Okay, then we need to install PCI separate. So that part we used to do. So that is not visible now, but in the behind it will work. So once we device driver executes, next comes BIOS, basic input output operating system. So that means what? Basic input here is what? Audio file is a basic input. What is basic output? Sound on the speaker. So should there be a synchronization between input file and output speaker? Yes. So that is done by basic input output device drivers. See the simple architecture of MS-DOS, Microsoft Disk Operating System. He will double click on some song file, so that calls open system call or a system program. So again that initiates a speaker. There will be a best synchronization between music file and the speaker. So whatever the file I am playing, I will get a audio as a output. This is simple structure of MS-DOS. Okay. So next, complex structure in the Unix. So what is a complex structure in the Unix? It has, first thing, it is a command based. That itself is complex. We don't have simple like double click on the file and copy something and paste it in the some other file. So for that we have to give a command. Okay. Less GUI, more CLI in the Unix. Less GUI means less graphical user interface. More CLI means more command line interpreter. Most of the activities we have to do with help of Unix only. Okay, so actually Unix provides best security. Okay, most of the software companies uses Unix as an environment for storing the database. Okay, so and also we should think about the responsibilities of kernel in the Unix. In the Windows we don't worry about what is the kernel is doing. Everything we will focus as I am the very important person, so computer has to provide me all type of service. But Unix is not like that. There I have to reduce my level and I have to think whether computer is getting a burden or not. If yes, I have to simplify the work. Like that, that means responsibility of user will also increases, because it is little difficult than the Windows what we are using. Okay, it provides Unix provides a file system, CPU scheduling, memory management. Everything is there like how we have a Windows, everything. But everything, most of the operations we have to give through the commands. What is difficulty of giving through the command? First thing, I have to remember the command. I have to remember its syntax. I have to follow it. If I have followed correctly, then only I will get the correct output. Otherwise, work is not done. Okay. So then comes traditional Unix system. I said so. It's here in the kernel. Okay. This is a kernel portion. User will give the commands through shell or the command prompts. So anything he requested will be provided as a service. But condition is what? He has to give in proper order. If he misses the order, so it will give us the request is not in the order, so we cannot provide the solution. Like that, it will be slightly difficult for user, or once he is thorough with that, again he feels like it's also easy. Okay, next comes layered approach. So hardware will be in the core, outside user interface. Okay, outside there will be user interface. User will give command. So then as from the one layer to the another layer, so the request is forwarded. So what happens? Definitely it has to reach the core. Okay, it has to reach the core. So from one layer to another layer, request is forwarded. If is it possible to solve by outer layers? If yes, solution is provided. If not, then it has to go for the hardware layer, get work done and give the answer. So advantage and disadvantage of layered approach. First thing, disadvantage of layered approach is it is time consuming. Okay, when service is first time. But if the service is already done just before you have done, so it will be time saving. See, justification, you have searched something in your Google. Okay, so like some IEEE paper you have searched based upon operating system. Okay, so what it will do, it is a first time searching in your computer or in your mobile, so it will take little time. So tomorrow again you will search same content. So what it will do, it will give answer little early, because yesterday's cookies will be stored. That means if the request is first time, it will take a time, but if request is repeated, definitely it can execute. So repeated services are provided by outside layers. If the request is new or the first one, it will enters up to the hardware. If not, it is solved only by the outside layer. Hence layered approach has both of the methods. Okay, so the microkernel here, the definition is by the name itself we can get. Earlier kernel means which provides all activities. Microkernel means remove non-essential, keep only essential, and that becomes microkernel. So one advantage is kernel itself is smaller, so OS, total size of the OS will be smaller. That is first. Second thing, in normal kernel mode, since we have all operations present, but we may use limited, whereas in microkernel whatever we want, those only we are kept. So definitely it is a faster. Okay, it is a faster. So one disadvantage is, if we want, we will define I am going to use only these many, but if suddenly situation comes that I want a new type of system call or a system program, then microkernel lags with that. Okay, so between the important case or the situation where microkernel is best suitable is establishing communication from one computer to another computer or one node to another node. So there it is very convenient because the works are very simple. One computer wants to connect with another computer, like a client and server or peer-to-peer. So whoever requests first, collect the request and forward it to the destination. That's it. Here work is very simple, and once the connection is done, computer 1 wants to send a message to computer 2, keep doing the same, like collect it from computer 1, forward it to the computer 2. That's the work of microkernel. Okay, so how it is, see this microkernel hardware is here, microkernel. You can compare this with, here you see this diagram, OS responsibilities. I think it is in the it was in the chapter 1 or here. Let's see. Okay, see here, this is how many services are here, 1 2 3 4 5 6 7 8, almost 8 services are here. But here what we have in a microkernel is the number of services itself is reduced, because we will remove non-essential for the case. Whatever we feel as essential, only those are kept here. So what are those? Inter-process communication, memory management, CPU scheduling. These are the only user kernel works. Operating system works. Hardware, so user will give some request. If it is possible to do, the work is done. Otherwise work is not possible to be done. So kernel is very small here. Earlier kernel was big because services were very high. Okay, so next is module method. So module method means what? We will try to divide all works into subgroups. Among each group we will try to keep correlated activities or services. So object oriented approach, okay, for a module. Then comes a core component as a separate, and each module will communicate with other to get a data or to transfer a data, etc. Okay, so in which platform module system is used is Linux and Solaris. Okay, so modules is the approach in which main OS is divided into subgroups. Okay, so it is a mixture of main kernel, main old or traditional method, as well as microkernel. See what happens, we will give a computer with a grouped or module based architecture of OS or a structure of OS. So here if I give that OS to school, they keep using only for the development of execution of a program, then execution of some paintings, etc. If that computer OS is given for railway station, they will use for limited works, online request, seat allocation, seat reservation checking, etc. The same computer OS is given for hospital. What they will do, they keep preparing a report of a patient, taking an appointment, etc. That means what? The subgroups, one subgroup will be there, that subgroup is frequently used in a category of users. Okay, so then comes hybrid. Hybrid means what? It may be mixture of all the above what we have discussed. What we have discussed is, first one was a simple structure, like simple structure, complex like a Unix, then comes layered approach, then a microkernel. So anything and modules. So these all, if they have acquired, took one parameter from one structure method, another parameter from another, and they will it will be derived with a hybrid, means it's a mixture of many facilities or system structures. So one of the example is Cocoa and Aqua. Okay, so Mac OS is a hybrid. It uses a layered approach, and it uses a Cocoa architecture. So that's one type of concept of how it is. From Aqua, it is a graphical user interface. Then with the help of graphical user interface, it provides many of the facilities. Then here using a Mac, it is a kernel based method. Okay, using BSD, it's a command based language. Input output kit and kernel extensions are the hardware type. So here this Mac OS is a hybrid. So as OS structures becomes hybrid, they become more and more popular. So for it is just like you can use that OS anywhere in the environment. There is a one OS which you can use, common OS which you can use in a school, hospital, railway station, etc. So Windows is also one type of hybrid structure, because you can find Windows in a school, Windows in a health center, Windows in the bus station or a railway station, even Windows computer in some research lab. So that means it's a hybrid. Okay, so how the operating system has generated. Okay, so it has been generated from the bunch of programs. So based upon the expected executions. So I want to execute some of the programs in as a student, with students. So I wanted student friendly operating system. Somebody else wanted research lab, so they wanted research lab oriented software or operating system. So third person want in the bank, so related to bank, etc. So that means what, operating system keeps on modifying or keeps on in providing a general solutions wherever it is required. Okay, so system boot. Okay, so system boot, very simple way. Whenever computer or mobile or any device is totally off, means switch off or shut down. After that, what we do for the first time supply, so there we will get a system boot. That means restart of hardware, software, kernel, user mode, all its applications. So that is called OS booting. Also we call system booting. System booting means configuring. So we used to do restart of the mobile, restart of a computer. That time what happens? All hardware stops executing, working. All software stop execution of a program. Then after some time they will start. You can see if you turn off the mobile, laptop or a computer, you not only operating system, also the fan will stops for a while. Again it will start a rotation. The fan, you can hear the sound. Okay, so that is called as system boot. So system boot we will get effect. The ROM is changes, RAM will changes, or the content in the RAM will be deleted and reloaded. So grub. Okay, grub is a command which clears all the information present in the basic memory elements. Okay, so that finishes chapter 2 of module 1. Okay, thank you.